Welcome to Chapter 7. This Chapter 7, 7 is going to focus on work and machines. So let's start off with work. In physics, work has a very specific definition. So you're going to do work when you exert a force that's going to cause an object to move in the same direction that the force was applied in. So work is done on an object when that object moves the same direction as the force that's being applied to it. That's what we call work in physics. So if there's no motion, then there's no work being done. You can sit there and you can push on your car all day and it will not move. Yeah, you will get tired, but according to our definition of work in physics, you did not do any work. So work requires a distance as a result of your force. That force also has to be applied in the same direction as that distance. So if I were to be going backpacking or something, yes, picking up my backpack and putting it on my back, I'm exerting a force in upward motion, and my backpack is moving in an upward direction, then I am doing work. However, if I were to be walking at a constant velocity, the only force that's being applied to my backpack would be the one that is keeping it up on my back. And again, that is also an upward force. However, motion in that case would be in the horizontal direction, and therefore work would not be being done if I'm moving at a constant velocity while carrying my backpack. Why this works is because work must be in the same direction as motion. If you're carrying an object at a constant velocity, the only force is in that upward direction, like I mentioned, and therefore the object is not going to fall because of that force, but it's also going to be moving in the horizontal dimension, and therefore the work or the motion of the object and the force being applied are in two different directions. So keep that in mind. We have to move something in order for work to be done, and the direction of motion and the direction of the force have to be in the same direction. So what about angles? So here we have Wheelie Backpack Kid. You can see that she is applying a force on this wheelie backpack in the direction of the white vector here. That white vector is actually a combination of the two yellow vectors, one in an upward force and one in a horizontal force. This horizontal force right here is doing work because the motion of the backpack is going in that direction. The other vertical force is not doing work. So in order to calculate work, we use a simple formula. Work equals force times distance. Again, it says two factors that matter, force and distance. So if I were to ask what takes more work, lifting 50 newtons up 1 meter or 100 newtons up 1 meter, well, work is force times distance. 50 times 1 is 50, and 100 times 1 is 100. So the 100 Newton force up 1 meter is going to require more work. Pretty simple calculations there. Force is measured in newtons, like always. Distance is measured in meters. But work is newtons times distance, so you could measure it in what's called a Newton meter, but we have a better word for that, and that's called a joule, spelled Joules, and that is denoted by a capital J. So 1 joule is equal to exerted 1 Newton of force over a distance of 1 meter. So if you were to think of how much force is required to move about a medium-sized lemon 1 meter, that would be equal to 1 joule of work.